All right, hello, my name is Giovanni Viscarando. I will be doing the Part A video for the final project for Dr. Osbe's Fundamentals of Aerodynamics class. So in this video, we will be going over the wing 2A, which is the rectangular wing with an aspect ratio of 10 and chord length of 1 meter. In this video, we're going to do the geometry. We're going to show the CL versus angle of attack graphs, the CL over CD versus angle of attack graphs, and the CD versus angle of attack graph. And then at 5 degrees, we're at 5 degrees angle of attack. We're going to plot the variation of the local lift coefficient, the induced angle of attack, and the induced drag coefficient along the span of the wing using the XLFR5. So let's open the XLFR5 app. All right, so now that we have it open, we're going to go to module. We're going to go to direct foil design. We're going to hit foil. We're going to do NACA foil. In the assignment, they asked for a NACA 2415 airfoil. So basically, we're just going to hit 2415, just like that. And then in the class that he went over, he did 150 number of panels. So we're just going to keep 150. We're just going to keep that like that. There we go. So that's going to be our NACA foil. It's so this way you can see the number of points. Boom, just like that. Um, Now we're going to go to module. We're going to go to X-foil direct analysis. We're going to go to analysis. We're going to do batch analysis. Here we have all the Reynolds numbers. It started off around, I believe it was 12 or 13, and then I added all of these by just, hitting here, insert after, and you can also delete them. So I'm just going to delete these two. Just keep it a nice 15. And then in the assignment, they ask for, um, it should change from -5 to 15 degrees with an increment of 1 degree. So that's why here we are going to have the minimum of -5, max of 15, with an increment of 1 degree. I had unclicked this earlier, so we're just gonna have it like that. And then everything else should be okay. So we're gonna hit analyze. We're gonna wait for this to compute. It shouldn't take too long. Analysis is completed. Excellent. So we're just gonna hit the back button, and boom, there we have our graphs. We have our CL versus CD, or CL versus alpha, CM. And we're not going to look too much into these right now, but what we're going to do now is we're going to design our wing. So we're going to go to uh, modules. Sorry, we're going to go to modules, wing and plane design. We're going to hit the plane. We're going to hit view, define new plane. We're going to unclick the elevator and fin. We're going to call this one, oops, we're going to call this AR10 because that's the thing. And then to define it, this part is a little bit weird. We're going to set it all to 1. I don't know why it looks like that whenever they don't delete fully. But yeah, so it says the chord lengths are going to be 1. We're going to set this offset to 0. Um, and then for the foil, we're going to do the NACA 15, the NACA 2415s. All right, so here we have our basic wing. However, we need an aspect ratio of 10. Look here, the y is 1, and the aspect ratio is 2. So the length is basically double the half. The wingspan is basically half the aspect ratio. So because half of 10 is 5, we're just going to change this to 5. And boom, look, now our aspect ratio is 10. Now we're just going to zoom out just so we can get a clear picture of it. And there we go. Now I'm going to hit save because everything else is correct. There we go. All right, now we're gonna hit save and boom, there's our wing again. Oops, zoomed a little too far out. Now we're going to go to analysis, find analysis. In the assignment, they asked for free stream velocity of 50 meters per second. So we're going to change this 10 to 50, and then everything else is going to be 5. We're going to leave it just the way it is. All right. And then make sure, yeah, everything else is going to be fine. We're just going to call this, I guess we could leave it like that. Doesn't matter too much. Oh, okay. We're going to call it AR10 again. Boom. Okay. And now we can go here. This is where we have our CD versus A, CL versus A, or CL over CD over A versus A, and then our efficiency versus A. Over here we have our sequence. We have our start, which is -5, our end, which is 15, and then our delta, which is 1. We're going to hit analyze. Boom. That's what it's going to look like. Here you can see the different points on where things are. Very cool. Um, yeah. 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 So again, in the assignment, sorry, they want us to find our CL versus angle of attack, which is going to be this one right here, CL versus angle of attack. It's a pretty linear line. The next one is a CL over CD versus angle of attack. It's going to be this one right here, CL over CD. Makes that nice hump right there. And then the last one they want is the CD versus angle of attack. There's going to be right here, CD versus angle of attack. Right here, we have our Oswald efficiency versus angle of attack. We didn't need to show this in this video, but we did need it for the project. Yeah, we're going to have that right there. It looks pretty nice. The next part we're going to do is at 5 degrees of attack. We're going to plot the variation for local lift coefficient, the induced angle of attack, and induced drag coefficient along the span of the wing. Now what we're going to do is we're going to head over here. Here we have the induced drag. So we're just going to unclick all of this. We're going to change this graph to, I apologize, fine graph settings. Local lift coefficient, which is going to be our first one. And then we are going to click 5 right here because it's asks for 5. Boom. One thing, just going to make sure the graph scales are right. Boom, there we go. This is going to be our local lift coefficient along the wingspan. So as you can see, starts at -5, which is one end of the wing, then goes to 5, which is the other end of the wing. And then basically to export this, hit current graph, export graph, and then over here you can name it. I would call it AR10. As you can see, yeah, I have it. I did it already. So LC is what I called it, local lift coefficient. Boom. So yeah, that's the local lift coefficient. The next one they ask for is the induced angle of attack. So we're just going to go here, right click. We're going to go to current graph, define graph settings. Let's see. And it asks for the induced angle of attack. I just want to make sure. Yep. Induced angle of attack, which is going to be this first one right here. And then boom, that's going to be our induced angle of attack right there. You would export it the same way to Excel. So there we have induced angle of attack. Make a other nice little hump. And finally, we are going to change it one more time to the induced drag coefficient, which it says right here, induced drag coefficient on the wingspan. Induced drag coefficient, we're going to right, and yeah, there we go, it goes up and down. Yeah, so that's just going to be how you do that for, and again, you do the same thing, export. Yeah, and this is at 5 degrees. Yeah, there you go. Gonna be all of part A. Make sure. Yeah, there you go. So that's gonna be it. I hope you enjoyed the video. Thank you for watching. Um, yeah.